What's going on, everybody? James here from Artificial Entertainment, and welcome to another Unreal Engine 5 tutorial. And today we're going to be taking a look at motion warp vaulting. So let's go ahead and dive in. So I have here a third-person project. Now this is in Unreal Engine 5.1, and I did make a few modifications to the default map, as you can see. And I created a simple animation blueprint, but I haven't done anything as far as what you're going to need to know for the vaulting system. This is just to cover over some of the things that you don't really need to know. Now, the first thing when it comes to motion warping, it is a plugin, so we need to enable it first. So we're going to go up to Edit, Plugins, and then we're going to type in Motion Warping or Motion Warp, and you'll see it right here. Now, one thing to note is that it does say beta, but it is a functioning plugin, so don't let this scare you. Now, as you can see here, it's going to say use caution when shipping, but it does work. Now, we're just going to go ahead, restart the editor, and we'll be right back. Alright, so now that we've restarted the editor, I want to talk a little bit about what motion warping is. So essentially, all it is defining a window within a montage to be able to say, okay, I want it to take this long to be able to go from point A, which is your current location in world space, to point B, which is going to be a defined location. So you need to set up some sort of system to be able to set appropriate locations for these endpoints, and you can set multiple. It's very, very easy and actually really nice because it works alongside with root motion. So what we're going to be setting up is going to look something like this, where we're going to be able to dynamically adjust height based off of the object, and there's a lot of other things that you can do with this system as well, but this is just one example where it'll literally just detect the height and be able to vault appropriately based off of whatever the detection is. And it's very smooth, very fluid, and will always provide the proper locations. So let's go ahead and I'm going to show you how to be able to set all this up. So the first thing that we need to do is we need to define a trace. So this way we can define what the height and land and depth locations and everything for the objects that we're detecting. So we're going to go into our third person blueprints and open up our BP third person character. Now I have set up a very simple sprinting function here, and I'll show you just really quickly. It's just a quick input. It's defining sprinting as true and just changing the walk speed because parkour always looks better with a sprint function. Now we also have the tutorial graph here, which is going to be kind of where we're going to code a lot of things. Now one thing I do advise is making everything in functions and kind of outputting things after. So that's actually going to be what we're going to do, and we're going to create a new function, and we're going to call this get initial object location. And now what this is going to do is essentially just go forward and out and be able to just tell us whether or not there is or is not something in front of us to vault over. So we're just going to pull off and go sphere trace by channel. And then the start and end, we're just going to do the usuals. We're going to get actor location, get actor rotation. Now, one thing I do like doing as well is pulling off at the actor location, getting a subtract node, and taking off maybe about 50 units from the Z, because realistically, unless you're vaulting over things that are going to be at or above chest level, you want to bring it down a little bit so this way it's able to detect things more at like waist or above. And from here, we can just plug this into the start. For the rotation, we're going to pull off, get the forward vector, pull off of this, multiply node, right click, and we'll convert the pin to a float single precision. So the standard line trace stuff, and this is going to be our initial trace distance. So we want to make sure that we set this to a decent value, but not anything too crazy. Otherwise, we'll be able to vault things that are, on the other side of the map. So we don't want to do that. We want to just make sure we can vault on things more close to our character. Now we'll go ahead and we'll set this into the end position. We'll set the radius to something like 10 and the draw debug type to 4 duration. Now we're also just going to put a branch, hook up the return value into the condition, pull off of the out hit, and break the hit result. Now what we want to do here is we want to take the impact point, promote to a local variable, and we're going to call this initial impact vector. And we're going to hook it up off of true. Now if it's false, we're just going to control D to be able to duplicate it, and we're just going to set it back to 0, because if it's 0, we don't want to do anything, but if it's, this, we want to be able to move forward. Alright, so now what we'll do is we'll compile and save, and we're going to go back to the tutorial graph here, and we're going to call this event. So right now, we'll just call it off a keyboard event E, and we'll plug this right in. So get initial object location right off of pressed. So we'll compile, save, and then we'll hit play. So if we go, and now you can see we've got, so it's happening a little low, so 50 might actually be a little too much. Maybe let's try just subtracting 30. It's kind of just playing around with it until you get to an appropriate value, something that's not too low or too high. Yeah, something about that. So like just subtracting 10 just to be able to get it slightly lower than the pelvis area. This way it's not actually going to detect anything too low or too high. So we're just subtracting 10. So I apologize about that. So let's go ahead, and now from here what we can do is we need to make another function, and this is going to be get object dimensions. So this is going to be a kind of a step trace where we're going to go through and trace the object several times. But what we need to do is we're going to go and put an input in here, and we're going to go initial impact vector. And we're going to change this from a Boolean to a vector location, because we're going to feed this in from here. Because what we can do is go back to our initial object location function, and we're just going to go get object dimensions, plug it in when we hit true, and then we're going to plug the initial impact vector into this. So this way we actually are setting it off of this and kind of just feeding it from here into here. Now from here things get a little bit more complicated, but I promise I'll try not to go too fast. So what we're going to need to do is we're going to need to first pull off of the execution pin here, and we're actually going to save the initial impact vector. We're going to right click and we're going to promote it to a local variable, and we'll just keep the name, initial impact vector. Oh, I forgot we can't name it the same. So we'll just call it initial impact location. Now, the only reason why we're doing this is so that we don't have to have pins going all over the place, because we are going to be using this location, but we'll just go ahead and save it so this way we can just use it as a local variable. Now from here, we're going to pull off the pin and get a for loop with break. And we're going to set the first index to 1. The last index, we're actually going to set to something high, like 50. Now, this doesn't necessarily mean that you're going to vault on objects all the way up on that distance, but it's going to basically just be going well beyond what you're going to need to ensure that it's going to fully trace the object. And you'll, again, see what I mean here in a moment. So we're just going to right click on the index, promote it to a local variable, and we're going to call this object height index. And then hook it into the loop body here just like this. Now off of the set here, we can just go and get a line trace by channel, and what we're going to do is get the initial impact location, and we're just going to subtract from it because we want to, because the initial impact location is more or less going to be right around the height of the object that you're going to be looking to start with. So we want to take it and subtract maybe like 20 or 30 from it just to bring it a little bit lower, just in case it's a lower object, because we want to bring this initial trace point below the top side of the object that we're tracing. And again, this will make more sense here in a moment. Just promise, I promise, and just trust me that we need to drop it just by a slight margin. But now we also need to get the object height index, and we're going to take it, pull off, and get a multiply node. Now we're going to multiply it by 5. This is because we want to get a nice tight trace to be able to ensure that we're getting the exact start and end points of the object, and it's not going to accidentally skip over and give us improper locations. Now from here, we're just going to take the output pin and we're going to convert it to a vector value, right click, and split the struct pin. And then we're going to pull off of this initial impact location that we're subtracting, and we're going to get an add node, and we're just going to put this on the bottom pin here because we want to split the struct pin here and just add the z values. Because what this is going to do is take from the initial impact location, minusing 30, so it's going to take it and drop it down a little bit. But then because we're looping it multiple times, it's basically going to go through and add 5 to that object z, that initial impact location, add 5 every single time it runs over and over again, giving us a nice spacing of only 5 units in between the actual traces. So that's what this actually does, is you're just multiplying it and then adding these two together to be able to make it so each time that it loops on the index, or loops on the this loop here, it's going to take that trace and adjust its value by 5. So now from here, we can just get actor rotation, pull off here, get the forward vector, and then we're going to pull off of here, get a multiplication node, and then again, just converting it to a float single precision. And we're going to set this one to around 100, even lower is usually better, maybe around 75. Because it's going to be starting almost exactly where it needs to be. So we don't really need to create as too long of a trace. It's just to be able to make it so that way it has a forward position. Now from here, we can just go and plug this into the start, take this, get an add node, and we'll plug this into the end. And then we're going to set the draw debug type to for duration, compile and save. Now if we hit play, just to show you, now we have that first trace going out, and now we have another series of traces going forward and up. Now, as you can see, the trace is going well above even the higher object that you would want to vault over. So that's good. That means that we have exactly what we need to happen. Now, the only difference we're going to do, though, is we're going to go out on the branch, create a branch on the out, and plug in the return value, take the out hit, and break the hit result, because we want to get the impact point, and we're going to promote it to a variable, because this one we're actually going to be using later. So this one is going to be the object height vector, and we're going to plug this off of true. Now, what we're going to do off of false, though, is we're just going to take this and we're going to plug it right into the break. So the second we don't get a hit, we're just going to go ahead and break it. But every time that we do get a hit, we're going to go ahead and just set that object height vector. The reason why I like doing this is because this means that it's always going to have a vector height, because it's starting from lower than where the object is actually, and it's always getting a hit no matter what it is. So we're going to go ahead and compile and save. And then now, as you saw before, it went all the way up. But if we go ahead and if I hit E now, it stops. It does one trace above, but that's okay, because we're not resetting anything off of that. We're just setting the information based off of where it actually hits from. So now from here, we're going to basically copy the same exact thing here. So we're going to take the for loop and the line trace, all of this. We're just going to take it, Control D, and we're going to take off the object height index, because we're going to create a new index this time. So we're going to right click, and again, promoting to a local variable, and this one's going to be object depth index. And again, hooking it up off the loop body there and plugging it into the line trace by channel. Now from here, we're going to get that object height vector, and we're going to get an add node, because we want to add a little bit to it. We want to kind of bring it up a little bit so that way we can trace downward. But we also want to get our object depth index. So every time that this loops, this is setting this index. And we're going to pull off, and we're going to again get a multiply node, again setting it to around 5. Now you can make this whatever value you want. Again, this is the spacing it's going to create between each individual looped trace. So if you set this to 10, it's going to double it. If you set it to 15, it's going to triple it. So it's however you want to do it. I like doing small values with larger trace numbers because it gives more accurate positions. So what we're going to do now, though, is we're just going to get the actor rotation. We're going to pull off, get the forward vector, and we're going to get that multiply node again. Now, what we're going to do, instead of right-clicking and converting it to a float single precision, we're going to take this object depth vector, or this object depth index, and we're going to plug the multiplication node right into the bottom here, just like this. And then we're going to add these both together. Now, this is a little bit of a vector math trick, where essentially you're giving a starting location and then giving a rotation point, usually an actor point, and then saying, do you want the forward vector, the up vector, the down vector, and then creating some sort of multiplication value. And as we discussed before, the object in-depth dex being a multiplied value on a vector means that it's going to multiply the vector by a certain point. So basically, it's going to go forward by 5 every single time it loops. So we can set this as the start point, pull off, subtract, and we're just going to subtract right around maybe like 75, or maybe we'll subtract 80. Actually, no, we'll set this original height object. We'll set the add to 30, and then we'll subtract 50. There we go. Now, the reason why I'm being particular about the numbers is because we want to raise it up just enough so that way it's going to kind of flow along the object and detect the object's depth. So how deep or how long is the object? Now, we also need to make sure that it's going to go down all the way, but also tell us when the object ends. So that's the reason why the importance of the math. So if I'll show you guys here. We'll take this little code piece that we made, and we'll plug in on completed. We'll plug it in so that way it runs this trace next. We will set the location values here in a moment, but we'll just compile, save, and we'll minimize. Now, if I go ahead and just hit E, you can see that there's only really one trace that's happening. If I increase this object's depth like this, we now have multiple traces running. So the reason why I like to do this is because it actually holds value for other types of systems, as well as certain defining points. So like if you want the objects, the depth to be within a certain value to do certain vault types, you can use this to actually help define whether or not you can or cannot do certain actions, because it's actually tracing the overall object's height and its depth. But now we need to go ahead and we need to actually set the depth index point. So we're going to do just like what we did before, pull off the impact point, promote it to a variable, and we're going to go object depth vector. And we're going to go off of true. And there we go. So now we have the ability to have a depth vector, we have a height vector. Now the last thing we need is the ability to set a landing point. So something on the other side of the object that'll say, okay, yep, we can go ahead and we can land. Now we're going to do this a little bit differently than what I've seen most people do. That doesn't necessarily mean that most people don't do it. It's just from what I have seen. So we're going to grab the line trace by channel. We're going to grab the object depth vector index. And we're also going to get actor rotation. Pull off, get the forward vector. Again, pull off, getting a multiply node. We'll go ahead and just align those here by highlighting and pressing Q. And then we're going to convert float single precision, and we're going to multiply it by 150. So what we're basically going to be doing is setting a landing position for this. So this is going to be the starting location. So we're going to go ahead and just add these together. So we want to basically, like I said before, we give a starting rotation value, what the forward vector value of that is, giving a multiplication of that value, and then giving it what the actual starting point is supposed to be. It'll then go from that point just with that rotation and vector value. So this was a way that you can kind of take a starting point, but put it in a different location in space and know where that location is if you're referencing it from a player actor. So we're going to take this and we're going to plug this right into the start node. But we're going to take off of this, subtract, and we're going to subtract right around, let's say 150. And we're going to set this as the endpoint. Now, we're going to set the branch and the break the out hit result just like what we did before. But the landing vector value is actually going to be set differently than the way that you might think. So just like before, we're going to set the impact point landing vector. So we're going to go, if it's true, we're going to set the landing vector right off of the impact point. However, what we're going to also do is if it's false, we're going to set it to the trace end. Now, the reason why I want to do this is because if you don't get a hit on the landing point, so like for example, if you're looking at a railing and there's no ground below it, but you want to be able to vault over the object, well, the only way to be able to do that is by continuing to give it a landing position. So rather than giving it the impact point if it doesn't get a hit, we're just going to give it the trace end instead. And we can even go trace end add, and because we're subtracting 150, we can just add maybe 50 to this. So this way it's only maybe 100 units off from where that initial object depth vector is. So like the top of the object. So it kind of goes down 100 units rather than 150 units. Now the reason why this can be important is because, well, realistically, if you're vaulting over an object, you don't want to be forced down too heavily because then it doesn't look real. It looks a little forced. I don't think it's a great way to do it. So I like setting a smaller value and just adding a little bit to it. So now if we go again off of completed, going into the line trace by channel, just like this. So what we can do is we'll right click, draw debug sphere, and we'll set the radius to 20, segments, we'll keep to 12, duration to 5, thickness to 3, and we'll hook both of these up, and we're going to duplicate this 3 times. So this way we can see all 3 points that we've just made. So we'll take the object height vector, depth vector, landing vector. And we'll plug all of these in as the centers for the draw debug. And we'll just go ahead and plug these in just like so. And then we'll compile, save. Let's see what we've done. All right, so let's go ahead and trace on this object. You can see we got 1, 2, and then a landing point. Let's go ahead and trace on this one. You can see we got 1, 2, just because the object is not very big. But because, again, you can see how we didn't get a hit, but it still gave us a landing position. But on this one, we did get a hit, so the landing position is on the ground. And again, same thing with this one. So because we're getting a hit, it's always providing a location, but even if the value of the height is a little too much, it provides a little bit of a different location, which is totally fine because, like I said, with vaulting over higher objects, you wouldn't necessarily be forced right to the ground. You're going to vault over and then fall to the ground a little bit. So it allows you to be able to have a little bit of a better realistic flow to what you're doing. So now that we've created the locations, now comes the fun part. Now we're going to use them in motion warping. So now that we have that function where we're going and getting the object dimensions, getting the initial object location, we can either create a new function or just do it right in here. I like to create a new function though, so it's really up to you, but I like functions. Functions are nice. So we're going to go set motion warp positions, and then we're going to, basically we can just take all 3 of these positions as the defining point. Now, because we added motion warping to our project, but we didn't add it to our character, it's not actually going to be something we can call yet. So we need to go up to the components tab here and type in motion warp and you'll see motion warping as an option. So if we go ahead and just compile that, we can now drag it into our graph here, pull off, and we're going to go add or update warp target. And then under the warp target here, we can right click and split the struct pin. So this way we can actually see the full structive information that we have here. Now you'll see that we have a location, rotation, warp bone name. We have a bunch of stuff that we can mess around with. But the main two things that we need are the location and rotation. Now the rotation is very easy. We're just going to get actor rotation, and we're going to plug that in as the rotation. Now you can also set it to a forced value if you're climbing. I'm going to do another video later on about doing climbing with this type of system, but for right now, we're just going to use the simple actor rotation. And we're also going to take the warp target name and name it to warp 1. And this is going to be the first point that we're going to use for our warping. Now, there's two different ways that we can go about this, but my personal favorite way is because when you vault over something, generally you're putting your hands kind of in the middle of the object. So if we go the object height vector and the object depth vector, if we get both of these here, so where the object starts and where the object ends at its top point. If we go pull off of one and get a lerp vector, push both of these together and set the alpha to 0.5. This is going to be a perfect middle between these 2 points, and we can set this as warp 1, or the initial warp target point. Because when you're vaulting, if you're vaulting over a short object, generally you're just kind of posting up on the object and then kind of using momentum to carry you over. So this is going to be that first point where we post up. The second point is going to be where we actually land to once we've actually completed the movement. So we're going to go ahead and get the landing vector here, and we're going to put this into the landing location, or the warp target location, I'm sorry. We're also going to take the actor rotation and plug this in to the warp target rotation here as well. Now, we don't need to mess with the warp target bone name. It'll automatically default to the root bone, so I wouldn't worry too much about that. Now, as you know, we have 3 locations, but we're only using 2 warp targets. And yes, we're using 2 of them here and 1 of them here, but you could also use these individually for different types of warps, depending on the actual animation that you have available to you. One thing that I do a lot is I'll set the object height, depth, and land as 3 separate warp points if I'm using something that like rolls or vaults heavily over the object. Now, we got to make sure to also put the motion warping into the target here because, well, it needs that. And we're going to set the warp point to warp 2. So now we can compile and save, and we're going to go back to the tutorial graph here, and we're going to right click and create a new custom event where it's just going to be vault over object. So what we're going to need to do, so with motion warping, if you're using anything that requires the movement of an upward position, you need to set movement to flying. Now, this can for some people, this is worrisome, but realistically, it's not a problem. Don't worry. So what we're going to do first, though, is we're going to set a variable, and we're going to call it busy. So this is going to be something to stop us from being able to call this again. So we're actually going to take this and get it, add a branch in here, and we're going to go, if busy is false, we can continue. But if busy is true, we can't. This is just, again, to help with repetitive calls. Now, from the vault over object, there's going to be a few different things we're going to do. First thing is going to be setting busy to true. And then from here, we also want to go ahead and we want to set movement mode to flying. Now we're also going to grab the capsule component, pull off of it, and set collision. And we're going to go set collision enabled. And we're going to set it to no collision. So this way it does not interact with the world. And now from here, we can just literally pull off and play montage just like this. Now, I like to use the regular play montage, not the one without the options here. Now, it doesn't really matter which one you use. I'm just letting you know that this is just my preference, which is why I'm pulling this one up. But the other one works just as well. But if you're using this one, as I always say, make sure you plug in that mesh component. Now, from here, we need a montage to be able to actually play. So we'll go ahead and compile and save, minimize. And in my tutorial assets folder here, go to my animations. And I got this dash vault here. Now, I've already created the animation montage, but I haven't actually done anything to it. I just I did the right click, create animation montage. Now, as you can see, this one does have root motion. I'll actually go ahead and I'll show you here. Now, to be able to tell if your animation has root motion, go to the asset details of the animation, not the montage, and type in root, disable the enable root motion, and see if you have movement like this. Now, if you have this, when you disable this, then you have root motion. And then you can just re-enable it and you'll see that it stays still. Another way to be able to tell is by going to the root bone on the skeleton tree and again disabling the enable root motion. And if you see that red line happening from where he starts to where he ends, then you can know that there is root motion. It's basically just meaning that there's our animation track on the root bone, which is basically the top hierarchy that controls everything. Now, I do recommend disabling root motion so that way you can see where the motion is supposed to be applied, as this does help with setting the motion warp positions. But we're going to go ahead, open up the montage here, and we're going to make sure that we have 2 notify tracks. You start with one by default, and we're going to right click, go to add notify state, and you'll see motion warping as a notify state. So we're going to set the initial position. And as I said in the beginning of the video, motion warping is allowing you to define a window. So this is that window that I was talking about, where you can go from your original location point, which is this point here, this one right here, and you can then go to the defined location, which we just set up with that trace, which is this point here. So we're going to go root motion modifier. We're just going to set the settings here real quick. And we're going to go, the warp target name is going to be warp 1 because that's what we named it. Now you do want to make sure that these names are exactly the same. So if we go over here and we look at the motion warp positions, we can see warp 1 with a capital W, warp 1 with a capital W. It's very important. We also want to make sure, very important, that ignore z-axis is unchecked because we don't want to ignore the z-axis. We actually want to use the z-axis because it has upward motion. Now from here, we want to just define where that first point's going to be. Now again, because it's using the root bones position, we want to look at where it posts up on the root bone section. So it's going to be right about here. Now we can also right click, add a notify state, add another motion warping state, because now we want to define that landing location that we made. So when we're going to set that one right about here, and we're going to make sure to go up to the warp target name, set this to warp 2, and ignore z-axis is also unchecked. Now there's one last thing that we need to do. To be able to ensure that the set movement mode to flying gets reset, as well as busy gets set to untrue, and all the different things that we set are, get reset to themselves, we're going to set up an anim notify. Now, if you've watched my videos, you probably know that this is one of my favorite ways to do things because animation-driven execution is actually very, very, very smooth, and I highly recommend it. So we're going to go and right-click, I'm going to go add notify state, new notify, and we're going to call this reset vault, just like that. And we're going to call it just before it gets to the position end, somewhere around like right here. You don't want to go too far back, but you don't want to be after it gets to the position. And then we'll go ahead and we'll just save this, go back to the BP third person character, and we're going to go back to the event graph and our tutorial graph. And we're going to create a second custom event, and we're going to call this reset vault. And we can just take all of this, duplicate it down, set busy to false, movement mode needs to be set to falling, and collision type for the capsule component, we're going to set to collision enabled, query, and physics. Now, in order to ensure that this gets called, we also need to go to our animation blueprint. So if we just open whatever animation blueprint you're using, it doesn't really matter. We just need to open it up, go to the graph here. So I've got the event graph open, and we can right click and look for that notify that we just made. So we're going to go reset vault. So it's right there, reset vault. And then we're going to grab our as BP third person character reference that is always inside of the animation blueprint. And then we're just going to pull off of it, and we're going to get the reset vault function, just like that. So basically we're going in on the notify, and we're saying at this point we want to be able to make sure that our collision component or our capsule is has collision enabled, busy is reset, and our movement mode is no longer set to falling. Now from here, we can just go and select the animation to play. So we have that montage that we just made those points in. So we can just stow that into our play montage by having it highlighted. And we can just click on the little arrow here for using the asset in browser. So now that we have all this here, we can compile and save. And you can see it's not doing anything. Now, there's a reason for that. And that's that we did not set the actual positions or the call for set motion warp positions. So that's my bad, guys. We're going to go ahead, we'll keep the draw debug spheres here, but we'll go set motion warp positions, just like this. So this way it'll go into the set motion warp positions, and at the end here, we're going to go into the vault over object. Because this way, it'll basically start here, get the initial object location. If it does get a hit, it's going to go in and get the object dimensions through this function here, where it's getting the height, the depth, and then the landing position. And then from there, it's setting those positions as motion warp targets, and then allowing you to be able to set the necessary variables, and then playing the animation. The animation is then causing, at the end, a notify to be fired that then goes ahead and resets the vault. Now, one thing I do need to just do really quickly is make sure that root motion is enabled on my animation, because in order to be able to apply the locations on our montage windows properly, I did disable it. So I'm gonna make sure that's enabled and save. And now if we go ahead and hit play now, we can go ahead and we should be able to vault very nicely. And you can see that it doesn't matter the location. I can go ahead and vault over as much as I want to. And again, even with lower objects, he's kind of pushing himself down and applying that vault accordingly. And because we're using the actor location, he's using the starting point of the vault's rotation no matter what happens. And you can see, like, even when we do this, once we get to that point, it puts us into that falling state. So you can use blends and things like that to be able to assist, but that's really it, guys. If you guys are looking for a more dynamic vaulting system or a motion warping component for you to be able to use inside of your system, I just want to announce that I am putting out a complete vaulting motion warping component that will allow you to be able to have a ton of different options pre-built, all the traces and everything you would need already built in with easy integration. So the demo video for that should be coming out soon, but at least now, if you, at the worst case, you guys can go ahead and set up your own vaulting systems. That'll look pretty nice. So it's really going to close it out for today, guys. Hope you enjoyed and I hope you learned something. If you have any questions, feel free to hit me up in the comment section or in the Discord. As you guys know, I try to keep on that stuff pretty regularly. But that's going to call it for now. Stay tuned, and as always, stay animated, guys.